Okay, we should be live. That's all working. There we go. Brilliant. All right. Let's go to my console. Welcome everyone to this week's episode of Techie Tuesdays. As you can see by the title, we're going to be analysing the Medusa ransomware. I believe it's Windows specifically. Let's have a look at the. See if Medusa ransomware. I believe it's Windows only. I will be analysing it on Windows today. So yes, it's using PowerShell and stuff, so it's most likely just Windows, but I'm going to be analysing a Windows exe. I'm currently on a development virtual machine, which means it has like debugging and reverse engineering tools on it. I'll be doing a quick dynamic analysis. If it has any problems to do with detecting my VM, because this is in a virtual machine, what I'm going to try and do, I'm going to attempt to patch it and get the full sort of cycle of the ransomware going instead of it just evading as soon as it sees sees either the AV or the VM. I have no automatic mitigations in place. In this current group scope, I am in detect on SentinelOne. Got all the detection engines on, no protect level, of course, and no containment. So I've also got anti-tamper on with snapshots. I want to just really specify that Medusa ransomware tries to delete virtual volume shadow copy services, the copies. SentinelOne actually protects them inherently, as it's part of the rollback functionality, which is patented to SentinelOne on Windows. So let's just get straight into it then. I believe if Medusa does happen to run on my VM, just a hypothesis, it will try to delete VSS copies. SentinelOne will detect it, but it won't necessarily mitigate the threat. It will just simply not allow it to remove VSS copies, because I've actually tried to do it myself, writing my own malware to attack SentinelOne, and it hasn't worked. That was just for threat testing purposes. So let's just see this one. This one was a month ago. This time a month ago. Roll down. And if you're watching this pre-recorded, and if you have any questions, put in the comments below. And if you're watching this live, I have the chat up just here, so I can respond to any questions if you have any. If you want to get in contact with us, you can get in contact with us at info@cybervigilance.uk. And then if you want to get in contact with me, the link is in the description as well. So let's just download the sample. I think this is a binary file. Let's go back. File name medusa1.bin. I want to try and find an exe. Hopefully this one. Is it just a raw binary file? Because it might be that it's trying to load a DLL, and I don't want to run a DLL. I want to just run an exe. Medusa1.bin. Might as well just try it. To get the download sample link. Scrolling is quite sensitive. So, download sample. Remember, when you are threat testing everyone, make sure you're inside of a virtual machine that's segmented away from your network, because I know Lockbit ransomware and many different types of malware will try and use network exploits to spread the malware laterally through your network. So I'm going to open up the zip file, and then I need to use 7-zip actually. Scroll up slightly. Minimize this. And what was it called? It was DD3. Let's open this up. And firstly, I'm just going to drag and drop it into the desktop so SentinelOne can do some static analysis. It probably will detect it with a file hash. But I'm not going to be focusing on that too much. password is infected. So it seems it's suspicious, and this is probably not to do with file hash. So SentinelOne most of the time puts file hashes as malicious and not just suspicious. So let's have a look at this threat. So let's go to incidents, and nothing's being mitigated at the moment. You can see I'm infected. Oh, it's okay. So AI confidence level is now malicious. Okay, so it's changed. Let's go into threat details. And okay, so on static write, AI suspicious. So it's determined it's malicious with the static AI on write suspicious engine. And you can see that there is these are not dynamically resolved imports. These are statically resolved. So the imports in this executable are used to raise kernel exceptions. So it's probably using kernel 32, plus it's unsigned. So you can't, so it doesn't have any of this built-in trust as an actual piece of software because it is malware. That's not to say that that signed binaries are safe, because we've seen signature hijacking before. So this binary uses Dinkelware libraries, commonly used by malware. This is something that will show up quite commonly in ransomware and sort of data damaging malware. So this binary imports debug functions too. So it's probably using is debugger present? That's the most common Win API, Win API tool to detect if it's inside of a debugger. It's easily patchable, but it's probably obfuscated, and you'll have to dynamically resolve the Win API call and patch it out during a debugging process just before it happens. And then it will probably try to exit the process if it detects it's inside of a debugger. So let's run it and see what happens. Again, it's SentinelOne detected that's malicious. It's now asking for admin permissions. I'm just going to say yes because I can roll back. It's trying to bypass UAC. You must restart your computer to turn off user account control. That is scary. Threat detected, so it's using SVC host to probably connect to the C2 server. Medusa also has a, I believe, if you look at, this is just an example of a sandbox that I found. If we go into the IOCs on the dynamic, there doesn't seem to be any network actions going on here. But I have seen on Virus Total, I saw that the IOCs the network actions were all internal, which likely meant that it was trying to do lateral movement, but I can't confirm whether it's done lateral movement or not. It seems that like it hasn't actually it hasn't ran because it's I think it's still dropping SVC hosts, but I think it might be detecting that inside a virtual machine, and I can be confident in this because if you go to malware bazaar, if you go back to malware bazaar, I'm not going to download it on this machine. Let's go to tag Medusa. I just want to show you something quite interesting. Let's go to this hash. Let's double check the VM. Doesn't seem to be encrypting anything. I want to check the threats quickly whilst it's loading. And 3 more threats. These are all by SentinelOne Cloud. This is a fake SVC host because it's using an extra T. That's quite sneaky what they're doing. And it's quite funny. But let's go back into here. And I want to bring your attention to Virus Total. And let's have a look at behavior. So at the top here, you don't have to be in behavior to see this, but you can see that it has direct CPU clock access. This is something that I believe is specific to 64-bit binaries. I've seen it really common with there's believe it's in Rust and Go. If this is written in Rust or Go, I can't confirm it for sure. But I know that there is a library which allows you to query CPU ID and see how many CPU cycles it takes. And depending on if it's over a certain amount of certain threshold of CPU cycles, it's inside of a virtual machine, and it's really hard to spoof that kind of stuff. So it's not like I can just remove. I'll give you an example. Like Redline InfoStealer has a module to detect whether it's inside of a virtual machine. Now, all it does is check, do you have a GPU or do you have a network, like a virtual network card, which is called VMware or VirtualBox or Zen. And that's like a really basic way of doing it, and you can spoof those really easily to allow malware to run on your test machine. However, spoofing CPU cycles is something that's extremely low level and it's usually proprietary, so you can't change anything. So what you have to do is you have to patch out that specific function. If you know about assembly, the jump statement is jump if 0, you need to change, or jump if not 0, you need to change that to a different type of, you need to change that to a different assembly code to jump it to the right function and allow the rest of the malware to run. Yeah, you can see it hasn't been running there. So I'm not going to mitigate the threat just now. I want to see what SVC host with the extra T is doing. It's the fake SVC host. So it seems to be, process creation. Fake SVC host is obviously not signed. I'm going to reverse engineer this now, actually. So let's boot up Ghidra. So we know for sure that this is malicious. I'm just doing this simply to, yeah, I think it, okay. For a minute, I thought it was going to be blocking Ghidra. My heart almost sank then. It might actually be blocking Ghidra. Okay, no, Ghidra's just a bit slow sometimes, so I agree. So if you have any questions, let me know in the chat. I'll be sure to read them. If you have any suggestions for another video, let me know. Try and get it sorted. So let's new project. And let's boot up code viewer. So I really like Ghidra in it and how it rebuilds the code in C from the assembly into C. I do prefer IDA's sort of functional code viewing, but yeah. So let's just load this. So it's called D3 DDE3 import file desktop. So hopefully the ransomware doesn't kick in now whilst I'm trying to do things on Ghidra, because it might break a few things, but at least then we'll know we have the functionality. So you can see that SentinelOne obviously reads file hashes dynamically using sort of process monitoring. Let's see how long this takes. And then you can see, but on the community for this sample of Medusa Ransomware, you can see the analyst verdict is malicious on VMware, Joe security, 100%. This is what I wanted to focus on, about how the hosts, these are all internal IPs. So it looks like there's some sort of internal botnetting going on when multiple devices are all connected, I believe. I can't say that for certain, but that's just what it looks like. Because obviously the C2 isn't the devices in your local area unless it's a botnet. So it's strange that it would be saying host, and it could be even considered a botnet at this point. But I know Lockbit does this usually. So let's analyze. Let's close this down. So let's go into functions and then entry. This is main. Then it wants to call. I'm still analyzing it at the moment. Calls two functions. I'm not too sure how I'll identify whether this is asynchronous or not, but it probably doesn't matter. Let's go into this function, see what happens. And what we're trying to see certain artifacts to see whether it's querying CPU ID or like current device information. So if this specific, if this variable equals this value, I wonder if we can, doesn't seem to be any different whether you change it into characters, octals, decimals, or binary. So if something equals something, then call a function. This function could either be calling the full functionality of the malware. I'm not 100% sure though. I'm not running this dynamically. Get system time as file time, get current thread, get process ID, query performance counter. So yeah, this is the anti-VM function. I was actually wrong. Because you can see get system time as file time. That's probably monitoring how many CPU cycles it has. I need to actually look this up. So get system time as file time API. So it's just okay. So it's just current system date and time. Give thread ID, query performance counter. Is this it? Query performance counter. Time interval measurement. So it's probably querying. This is probably the function that it's using to query a large integer, and then it will return, and then obviously unstack everything. That seems to be what it's doing. This seems to be sort of like the general reconnaissance of the device. So let's just. This is definitely one API. Here you can see it's got the kernel functions that aren't dynamically resolved. If the malware developer wanted to do things better, they would be dynamically resolved. And this wouldn't have been able to be detected by SentinelOne because what they usually do is that they create an array of the individual characters of the Win API, and they'll obfuscate that, encrypt it, and then during runtime, when it's decrypted, it will be in runtime where actually query that Win API command and unblock the array and that kind of stuff. So you won't see these static kernel imports, which is possibly a design flaw. I know, but I know that some AVs don't actually detect this sort of stuff, so it's probably bypassing those sort of things. So that's just a quick analysis of Medusa Ransomware. If you enjoyed this video live stream, give it a like. You can subscribe to us. I'll just check for any questions. It's all good. And yeah, I'll catch you guys next week. Thank you very much.